Hey everyone, welcome back to another video for the second order linear differential equation series. So for this video, we will still be doing or trying to solve a second order linear ODE based on these three cases. But the difference between this video and the previous video is that the previous video we've been solving second order linear ODE just to find the general solutions, but in this video we will be solving second order linear ODE with initial value condition or initial value problems that will give us a particular solution in the end. So without further ado, let's go to the first problem. Hey everyone, so this is our first example for today's second order linear ODE with initial value problem. And our very first step will still be the same like we've done in the previous video, whereas the second order linear ODE, but without the initial value problem. So let's rewrite this expression or this differential equation becomes r squared minus 49 equals to 0. And now let's factor this to find its roots in order to determine which of the three cases that we're going to use based on its roots. So we know that r squared minus 49 becomes r plus 7 times r minus 7 equals to 0. And we know from here that we have two roots, which the first root is r1 equals to negative 7, and the second root becomes r2 equals to 7. And now we know out of the three cases, we're going to use the case one, which it has two roots in it. And therefore, our general solution here becomes y equals c1 times e to the r1 times x, which becomes negative 7x, plus c2 times e to the r2x becomes 7x. And usually we stop right here in the previous video since we just want to find the general solution because there is no initial condition given at the start of a problem. But now the concept is still the same. But in here, you'll realize you've been given two initial conditions. That's why you will need to find two constants of C1 and C2. And first, let's try to replace the x's with 0 using the first initial condition and the y's with 1. Okay, so first, 1 equals, let me write on the side here, y0 equals to 1. Okay, so we're using the first initial condition, which is 1 equals c1 e. Negative 7 times 0 is just 0, plus c2 e. 7 times 0 is also 0. So this will become c1 plus c2 equals to 1. And first, let's skip this expression, okay? Because we're gonna need it later by solving using the system of linear in order to find C1 and C2 using elimination and substitution. And we're going to use the second one now, which is the y derivative of 0 equals to negative 1 here. Okay, so let's take the derivative of our general solution here first. Okay, so the derivative of this is equals to c1 e to the negative 7x becomes negative 7 c1 e to the negative 7x plus c2 e to the 7x is just c2, 7 times c2 e to the 7x. And after we take the derivative of this expression, or our general solution, now let's replace the y with negative 1. And let's replace all of the x's with 0 again. So negative 7 c1 e to the 0 is just 1, so let's just not write it, plus 7 times c2 times e to the 0. E to 0 is another 1, so this will become plus 7 c2. And we've got another expression here that we can use to help in our solving linear systems, okay? So let's do an elimination process right here. We've got before negative 7 c1 plus 7 C2 equals to -1, and we've gotten our first expression, which is C1 plus C2 equals to 1. And now let's try multiplying the bottom part by 7. So we're multiplying this part by 7, and we'll multiply this part by 1. So it stays the same. And we're gonna subtract everything. Or let me put this outside so you're not gonna be confused of it. Okay? So 1 times -7c1 is just -7c1, and 7 here times c1 is 7c1. So let me write down here so you'll not get confused. Okay, 7c1 plus 7c2 equals to 7. So let's do the subtraction of this one. -c1 minus 7c1, it's just -14c1. And then 7c2 minus 7c2 is just 0, so we can ignore that one. So it is crossed out with everything. And therefore, -1 minus 7 is -8. This one is equals to -8. And then we can remove the negative signs because they cross out with each other. And then C1 is equals to 8 divided by 14. 8 divided by 14 is 4 over 7. 4 over 7. And we've got for our C1. Now, let's substitute our C1 to C1 plus C2 here to find for C2, because that's the simpler expression that we can use to find C2, okay, rather than using this expression right here. So let's write it down again. C1 plus C2 equals to 1, and we know that C1 here, we've got it, which is 4 out of 7. So let's replace C1 with 4 out of 7 plus C2 equals to 7 out of 7. It's easier to see this way for the subtraction later on. And now let's subtract both sides by 4 out of 7, since we want to get rid of the left hand side for 4 out of 7 in order to find for C2. And our C2 here will equals to 7 out of 7 minus 4 out of 7 is just 3 out of 7. And so we found our C1 and C2. And our last step here will be substituting our C1 and C2 into our general solution here that we found before. So our final solution right here will be y equals to C1. C1 is 4 out of 7. 4 out of 7. Let me make that a little bit more clear. 4 out of 7. E to the negative 7x plus, and C2 here is 3 out of 7. So this 3 out of 7 e to the 7x. And this is our final solution for our first example in order to solve for second order linear ODE with initial value problem. Hey everyone, this is our second example for today's second order linear ODE with initial value problem. We've got here y double xn or y double prime minus 6y xn plus 13y equals to 0 with an initial condition of y0 equals to 1 and y xn 0 is equals to -1. So first, let's rewrite this differential equation like what we've always done in the previous video and example into r squared minus 4r plus 13 equals to 0. And since it is hard to factor this out normally, let's use the quadratic formula to save the time. So if all of you still remember, the quadratic formula is r equals to -p plus or minus p squared, square root of p squared minus 4ac over 2a. And for the a's, for the a is the constant in front of r squared, the p is the constant in front of the r, and the c is the constant here, just positive 13. So let's plug off the a, b, c in order to find our roots here. Negative b here is negative 4, so it's just a 4 plus minus square root of b squared. B squared is negative 4 squared is just 16 minus 4 times a, 4 times 1 is just 4, and 4 times 13 is 52. So this minus 52. Everything is over 2a, which is just 2, because it's 2 times 1. So let's solve for this one. 4 plus minus 16 minus 52 is just negative 36. So let's write down here negative 36 over 2. And we know that in here, inside of our square root, we've got a negative integer. Whereas if we know that there is a negative integer inside of our square root, we're dealing with complex numbers, which we will have an imaginary root in the end. So we're gonna use case 3. And so 4 plus or minus 6i here over 2. And we can simplify this by dividing the numerators by 2. And this will give us 2 plus or minus 3i. Okay? And so we can write down our R1 here is equals to alpha plus beta I. Let me write that down more clear. And our R2 here is alpha minus beta I. And our R1 here is just 2 plus 3i. Our R2 here is 2 minus 3i. And so, by knowing that we're going to use our case 3 for this problem, our general solution here will be y is equals to e to the alpha x times everything inside the bracket c1 cosine beta x plus c2 sine beta x. And now let's plug in for our alphas and betas here. And our alpha is just 2, so e to the 2x times c1 cosine beta x. Beta is just 3, so it's 3x plus c2 sine beta x, and beta is just another 3, so it's 3x again. And from here, usually we stop at this step since we want to find a general solution, but we have an initial condition. Remember, we've got two initial conditions here in order to find for C1 and C2. And so let's find for our C1 and C2 by first plugging in the first initial condition right here, which is y0 equals to 1. So let's use our first initial condition, y0 equals to 1 here. And let's plug in the y with 1 and the x's with 0. So 1 equals e to the 2 times, let me write it here. 1 equals to e 2 times x, 2 times 0 is just 0, times c1 cosine 3 times x, or 3 times 0 is just another 0, plus c2 sine 3 times x is 0 again, so this will just be another 0. And then from here on, we know that e to the 0 is 1. So if we divide both sides by 1, it's just 1. So this is 1 equals to c1 times cosine 0. Cosine 0 is 1 here. Let me write down here. Cosine 0 is 1 and sine of 0 is 0. And then we know that we found the c1, which is 1. And let's keep our c1 and find for c2 now. And for c2, we're gonna need to use our second initial condition, which is y-axis 0 equals to negative 1, which first we need to find for our y-axis first, which if we take the derivative of y here, y-axis equals to Let's distribute everything inside so it will be much more easier for us. So first let us rewrite our general solution into this form: C1e to the 2x cosine of 2x, or 3x I mean, plus C2e to the 2x times sine of x, or sine of 3x. And you'll know why I distribute all of the e to the 2x inside the bracket. Since now we have a new expression, or since after we've distributed the e to the 2x inside, we can take the derivative of it and use the initial condition later. And you're gonna realize that we're gonna use product rule for the left hand side and the right hand side, which this is the left hand side, this is the right hand side, okay? So for the left, and you all know the product rule is just uxn times phi plus u times phi xn. And so for the left hand side, c1e to the 2x is a u, and cosine 3x is the phi. So if we take the derivative of u first, this will become 2c1e to the 2x cosine 3x plus u, which is just c1e to the 2x, and we're taking the derivative of cosine 3x, which becomes negative 3 sine x. So we can write it down like this one: negative 3 c1 e to the 2x sine of 3x. And let's just put a bracket over here so we don't get confused which product rule or which sides are we working on. And now let's work on the right hand side, which is c2 e 2x times sine of 3x. So we're going to do the same steps, which we're going to take the derivative of c2 e to the 2x since it is the u. This will become 2 c2 e to the 2x sine of 3x plus the derivative of sine of 3x is 3 cos sine of 3x. So this will just become 3 c2 e to the 2x cosine 3x here. Okay, so we found our derivative for y here, and now we can just plug in 0 for x's and negative 1 for y from the initial value condition given up here, our second initial condition, which is y(x) of 0 equals to negative 1. Now let's plug it in. Our y is negative 1 equals to 2 times c1 e to the 2 times x. X is 0 again here, so e to the 2 times 0 is just e to the 0 plus or minus 3 c, oh, we almost forgot the cosine of 3x here, times cosine of 3 times 0 is just cosine 0 minus 3 times c1 e to the 2 times 0 is 0 times sine of 0, because 3 times x or 3 times 0 is just 0, plus we're going to do the same thing again right here, plugging in 0 for the x's, 2 c2 e to the 0 sine of 0 plus 3 c2 e to the 0 times cosine of 0. And from here on, we know that our sine of zeros are zeros and our cosine of zeros are ones. And then we can solve for this equation to find for our C2. Negative 1 equals to 2 times C1 e to the 0. E to the 0 is just 1. Cosine of 1 is just 1. So this stays 2c1. And on the right hand side here, we know if we multiply everything by sine of 0, which is 0, which will be equal to 0, so we don't need to write that one. So this is just 2 times c1 minus or plus 2c2 times e to the 0 times sine of 0, another 0 here, so we don't need to write that the left hand side here. But on the right hand side, plus 3c2 e to the 0 times cosine of 0. Cosine of 0 is just 1, e to the 0 is 1, so this will be plus 3c2. And then we will get 5, or actually 2c1 plus 3c2 equals to -1. And how do we solve this to find for c2? Remember that we've got our c1 here, which is equals to 1. And let's just substitute it, our 1 here, which will give us 2 times 1 is 2, plus 3c2 equals to -1. And now let's subtract both sides by 2 to remove the 2 on the left hand side here. And this will give us 3c2 equals to -3. And we know that if we multiply both sides by 1 over 3, and also the right hand side here, 1 over 3, we will get c2 equals to -1. And by then, we found our c1 and c2, and our final answer. We just need to use our general solution here and replace or substitute our c1 with 1 and our c2 with -1. And so our final answer right here will be y equals to e to the 2x times c1 is 1, so we don't need to write that one, cosine 3x. Our c2 is -1, so this changes to negative, minus sine of 3x. And this is our final solution for example number 2 towards second order linear differential equation with initial value problem.